Welcome to today's lesson over systems of linear equations in two variables. Let's start with number 2. Number 2 states to substitute negative 2x plus 2 in place of y in the following equation. Here is my y variable in the equation, so I'm going to take 5x plus 3 and substitute the negative 2x plus 2 in place of the y variable. Now I need to simplify this by distributing the 3, then adding the 2x variables, subtracting the 6, and then dividing by negative 1. Therefore, I've answered the question of substituting the negative 2x plus 2 in place of y. Then solving for x. We solved for x by getting the result that said x equaled a number. Let's move down to number 4, which is very similar. This one states to substitute negative 4y plus 5 in for the x variable in the given equation. Therefore, I will have a negative 5 times the new value of a negative 4y plus 5 minus 4y equaling 2. Once again, I distribute my negative 5, resulting in a 20y minus 25. And then I need to clean up this equation. So the 20y minus 4y is 16y. Add the 25, and then divide by 16 and get a rather unusual looking answer, but that is the correct result for the y value. Let's now look at number 8. We have two questions here. One is to solve for x, meaning write the equation so it states x equals, and then part B would be to solve the equation for y such that the equation says y equals. So in number 8, if I begin by solving for x, I would move the 1 to the other side of the equation by adding 1. And then to get my x isolated, or to solve the equation for x, I would divide everything by 4. This would be the equation solved for x. Part B states to solve for y. I can start where I just left off, or I can begin from the given equation. If I continue from the x equals version of the equation, solving for y, I would subtract 3/4 off of each side of the equation. And then to eliminate the fraction, I would come in here and I would multiply everything times 4. That would result in a 4x minus 3 equaling a negative 5y. My last step would be to divide everything by 5 by a negative 5 in order for this to equal y. And to be more specific, I think I would rewrite it as y equals, so that I answer the question by solving the equation for the y variable. Let's move to the next topic, which is topic 3. It states to write the equation in the form, or the standard form, of ax plus by equaling c. The a, b, and c are numbers, and it states that the a must be positive, and a, b, and c, the numbers, must be integers. So integers do not include fractions. They can be positive or negative, but no fractions and no decimals. So if we come in here and look at number 14, every one of these coefficients of these variables are decimals. In fact, a would be the 0.25, b would be the negative 0.04, and c would be the 0.24. So I would come in here to clear the fractions and multiply every term times 100, which would result in a 25x minus a 4y equaling 24. This is now in standard form, where the a value is the 25, a positive value, the b is a negative 4, and the c is 24. There's no fractions, no decimals, and a is a positive value. Now I'm going to back up and look at number 10. In number 10, this is not in the ax plus by equaling c form. In other words, you're supposed to get your x's first, then your y's, then your equal, and then your constant. So my x is on the left, but I need my y to move to the left, so I would subtract 7y from each side of this equation, resulting in a 2x minus 7y plus 2 equaling 0. Make sure you do not lose your equation. You maintain the equals 0. Now I would need to move the constant to the right side of the equation, resulting in a 2x minus 7y equaling negative 2. This is in standard form. X's, then y's, then equal, then your number. My a would be a 2, which is a positive value. My b is a negative 7. And my c is a negative 2, and this is in standard form. Now let's make a connection to college algebra by solving systems of equations. Number 1 requires us to solve using the substitution method. To do this, one of our equations needs to say x equals or y equals. Neither equation is stated as such. So let's take the first equation and solve it for x by subtracting 2y from each side of the equation. Therefore, one of my equations is solved for the variable x, which places me in a position in which I'm ready to use the substitution method. At this point, I take this value for x of a negative 2y plus 16 and I substitute it into the other equation in place of the x variable. This would now become 4 times a negative 2y plus 16 plus 3y equaling 29. I now distribute my 4. I simplify the equation by combining the y terms. I then come in here and I subtract my 64 off of each side. And divide by a negative 5. At this point, I have the y value. Now remember, when you're solving a system of equations, your goal is to get the x and y value. So we have half of the solutions. We now need to go back and determine what the x value is. If I return to my x equals equation, which has some highlighting in it, which is x equaling a negative 2y plus 16, and substitute my found y value of 7, I then can get my resultant x value, which is 2. So x equaling 2 is my x value solution. Therefore, my solution is that x is 2 and y is 7, and often the solution will be written as an ordered pair. Let's solve the system of equations in number 2 using the addition method. In other words, we want to add these two equations together. When I add the equations together, I want one of the variables to add out to be 0. So if I choose to pick on x, I have a 7 and a 3 which add to be 10. I want them to add to be 0. If I multiply the entire top equation times negative 3 and the entire bottom equation by 7, then I would get a negative 21x on the top and a positive 21x on the bottom, such that when they are added, the result would be 0. This would be, when I multiply through times the negative 3, this would be a negative 21x minus a 39y equaling a negative 232. The bottom equation would become 21x minus 63y equaling a positive 28. Now when I add the equations together, the x will drop out or add out as 0. Then I will have a negative 102y equaling a negative 204. I can now solve for y by dividing by the negative 102, getting my solution for my y value to equal 2. So again, my solution really is to find both the x and y value, and I now have the y value. To get the x value, I substitute this y value into one of these equations. It does not matter which one. I'm going to just randomly pick the 3x minus 9y equaling 4. If I plug the y value of 2 in to this equation, I will result in a 3x minus 18 equaling 4, a 3x equaling 22, or x equaling 22/3. So my solution would be that my x value is 22/3 and my y value is 2. Often we would write this solution as an ordered pair in presenting this answer. I hope this was a helpful recording for you in understanding systems of linear equations. Have a great day.